Okay, number 3. A heavy object is dropped from a vertical height of 8 meters. What is its speed when it hits the ground? We don't know how heavy it is, but that really shouldn't matter. And again, kinematics could be used. I'm not going to show it this time. I'm going to dive right into this work energy approach. So, solving this out here, I'm going to say that we know that it was dropped. Dropped tells me that its starting speed was 0, as opposed to a throw or some kind of other launch, from a height, h, of 8 meters. What is its speed when it hits the ground? So at the ground, its height will be 0, and its speed is what we're looking for. I'm going to roll right into my conservation of energy equation. The energy that it ends with is equal to the energy it started with, allowing for the possibility, although again, not in this case, that non-conservative forces might have been at play, like friction or had there been air resistance, etc. But we're idealizing things. We're assuming there was definitely nothing acting other than gravity, which is exempt from that part of the equation. M prime is the total of kinetic energy and potential energy at the end. M is the sum of kinetic energy and potential energy at the start. And again, a couple of these things are 0, so we can cross them out. At the end, it's at the ground level, which we're designating the 0 point for height, so there's no potential energy there. It was released from rest, so there's no kinetic energy at the start. So what that amounts to is that 1/2 mv at the end squared is equal to mg height at the start. Again, m will divide out just like it did in the last problem, which means that we can calculate the value of, what are we looking for? Oh yeah, v prime. We can solve for v prime, no problem. V prime equal to the root of, and I can actually clear this 0.5 just by multiplying both sides by 2, so I'm going to do that, 2gh. So v prime equal to the root of 2, g is 9.8, and h was 8. So 8 meters, root of that. V prime equal to, get this into my calculator, square root of the following, 2 times 9.8 times 8, and I'm getting an answer of 12, rounded off to 0.5. 12.5 meters per second. And there you go. Problem number 3, 12.5 meters per second.